Hello! This episode for Algebra 2, we're going to be reviewing rational exponents and radicals and the relationship between those two. First part being English, and then en la descripción voy a poner la parte en español. Well, before we move on to these types of problems, we really need to understand what a radical expression is and what a rational exponent means, an expression that has a rational exponent. Well, first of all, an expression or a term that has a rational exponent, it just means that your exponent is a ratio, and a ratio is another word for a fraction. So we're not dealing with necessarily whole numbers, although technically you could consider this a rational exponent because a whole number, like 2, for example, can be rewritten as a fraction of 2 over 1. We all see. So this would be, if I write it this way, for example, it would be considered a rational exponent because the exponent is a fraction. Now, a term with a rational exponent can be rewritten as a radical. A radical, for example, here, in this case, this is radical with index c, and c just represents any number. The index is a little number that is right right outside the radical, and it's a small number, like a kind of like an exponent, but it's on the left side. So not to be confused with a coefficient, that's not the same thing. If you have a large number in front of this radical, you're multiplying, so it's a coefficient. In this case, the index is a small number on top. And the expression inside the radical, so this is the radical, the name of that symbol. We call it the radicand. And the exponent of the radicand is here. So we can transform this radical expression, rewrite it as a rational exponent expression. Let's do a few examples, easier examples, and then I will erase and we'll do some other examples. First of all, I'm being asked to convert. So you're being given a radical expression, use the rule to convert it as a rational exponent. If you're being given a rational exponent expression, you need to use the rule to convert it to a radical. So first, I'm going to just make a note here. When you don't see an exponent, the invisible exponent is 1. So I'm going to put that there. And I'm actually going to put it here as well. Y has an exponent. If you don't see it, it's 1. Now, here the index, the little number is 3, but here you don't see an index. So if you don't see an index, the invisible index is 2. So, for example, if you don't see an index, you can also call this radical of index 2. It can also be called the square root. So when you don't see an index, go ahead and put the invisible index of 2. So far, we're at least in a good place, and we can continue. This is the base of the radicand, so the base stays the same. And I'm going to draw the line that represents the fraction of the exponent. The exponent of the radicand becomes the numerator. The index becomes the denominator. And I'm done. I just used this rule. Now I'm going to go on to the next one here. I have the same base, and then I'm going to write my line for the rational exponent. My invisible 1 exponent here becomes my numerator 1. My invisible 2 that I had to draw in for my index becomes the denominator, and I'm done. Now here, we're going the other way, and we can't do that because an equality sign says you can go either way. A equals A, if you flip it, A equals A. So here we have c to the power 1/2. So here's the rational exponent where it's 1/2. The same base, I'm going to go ahead and draw the radical symbol. The numerator, again, is the exponent of the radicand, the expression inside the radical. And the denominator is the index. And again, I'm drawing it small, little above the tail. I'm not drawing it big because then it'll be confused as a coefficient. And then here, similarly, I start with the same base. I'm going to go ahead and draw the radical symbol. It's the numerator is 1. So the exponent is 1. The denominator 7, so the index is 7. Now, your final answer, before we move on to this one, there's nothing wrong with this. However, we know that typically when your exponent is 1, you don't draw the exponent. You don't write it. You just leave it out. You know that there's no exponent. We know that the exponent is an invisible 1. Excuse me. And then similarly, if we know that the index is a 2, then we don't put it there. There's an invisible 2 there, but only when the index is 2 and the exponent is 1. So this would be the end here. And similarly here, the way you would actually write this in the most simplified form, you would just drop the exponent of 1. Oops, you would drop it completely. Now, I'm not going to drop the index of 7 because otherwise, if I drop it, it's going to send the message that the invisible index is 2, but we see that the index is not 2 because the denominator is 7. So I need to make sure that the index is the same as the denominator here in order for it to be a correct, equal representation of this expression. So this expression, x to the 1/7, this rational exponent expression is the same as this radical expression. Why? Because we are applying this rule. Let's take a look at this one here at the bottom. I'm going to start by writing the same base and the radical expression. I'm not going to put the 1 there because I know that the numerator becomes the denominator, but typically we don't use the 1 there. And then we have the 4 here as the index because again, the denominator becomes the index. So now I'm going to pause. Okay, we're going to move on. Hello, I am now going to take it a step further, and I'm going to bring something to your attention that you may or may not have been aware of. This expression here, this radical expression, is equivalent to the expression where the exponent inside the radicand can be also written outside. It could be the exponent of this expression. Now we're going to prove that using the rules of exponents. Okay, but first we know PEMDAS. First we're going to actually just look at what's inside the parentheses. So this radical expression, we're going to rewrite it as a exponential equations with rational exponents, and then we're going to look at the rules of exponents to see how the rest comes into play. So again, I'm going to just leave the exponent outside alone, and I'm going to rewrite what's in the radical expression inside. So the base is the same. We know that there is no exponent. It's invisible 1. So the exponent then becomes the numerator 1, fraction, and the index is the denominator. So far we have this radical expression inside can be rewritten as x to the 1/c power. So now we're here, we look at this. One of the earlier rules that you learn in math is that when you have a term to the power and you're taking it to another power, you multiply the powers. So this is equivalent to x to the 1c, that looks like a 6, my apologies, 1/c times b. Now, one thing to remember, if you don't remember, all all whole numbers, like 4, for example, can be written as 4/1. It's the same thing. Hence why all whole numbers are also considered rational numbers, because a rational number is any number that can be expressed as a fraction of 2 integers, 4 and 1, or 2 integers. So when you're multiplying a fraction with a whole number, there are 2 ways to do this. You could turn your whole number b into b/1. And when you multiply a fraction, you multiply the numerators together. So 1 times b is just b. And then you multiply the denominators together. C times 1 is just c. So notice I got the exact same expression as I did here. Hence why this expression, radical index c to the power of b, is the same thing as this expression, where the exponent can be written inside the base, or it can come out as the exponent of this entire radical expression. So let's take a look at a few examples. We have the first 2, we have exponential expressions, and we want to rewrite them as radical expressions. Okay? So this is equivalent to the the base is the same. I'm going to go ahead and put my radical symbol. The numerator is the exponent of the radicand, and the denominator is the index. Like I said, you can also rewrite it as the same expression, except the 2 comes out, but the index 5 is the same, and the base is the same. So both are correct, both are good ways to write it. Let's do this one. The base is the same. We'll go ahead and draw the radical expression. The numerator is the exponent. The denominator, 7, is the index. And that's one way of writing it to get the correct answer. And the other way of writing is the 2 comes out. In this case, it just happens to be the same numerator. The index stays the same, and the base here stays the same, but the exponent comes out. They're both equivalent. Now this here, we want to write it in exponential form, this expression. And we know because these are radicals, when we rewrite it in exponential form, we're going to get a rational exponent. So the base is the same. And I have a index is my denominator, and the exponent here becomes my numerator. And we're going to leave it like that because we want to leave it in exponential form. Here, let's take a look at here. Again, we're going to rewrite it in exponential form. The base is the same. And notice the exponent is the numerator. And here, the exponent is outside. The expression here is inside, but you're still following the same rule like I explained here. And the index becomes your denominator. And then here, again, same base. We have the exponent is my numerator. The index is my denominator. And I can simplify this. 6 divided by 3 is actually 2. They're both correct, but this is a more simplified version. Okay? I'm going to do it in Spanish now. No voy a explicar completo en castellano porque como se dan cuenta que estos tipos de ejercicios no son tan complicados, pero sí voy a explicar el trabajo que está aquí en la pared. Aquí hay una regla y como se dan cuenta, esta es una expresión radical. Aquí tengo X, donde el index es C y el exponente es B. Yo puedo escribir una expresión radical como una expresión exponencial donde el exponente es una fracción, a rational exponent. Por ejemplo, si yo tengo aquí una expresión y al poder de 2 sobre 5, yo puedo escribirlo usando esta regla como un radical, donde el numerador se convierte en el exponente y el denominador se convierte en el index, en el número chiquito, no número grande, el número chiquito que va aquí arriba. Otra manera de escribir esa expresión es está correcto, donde el exponente sale afuera. Aquí yo enseñé en inglés cómo esta expresión es igual a esa expresión. Por ejemplo, usando la regla de PEMDAS, sí, yo puedo convertir la expresión adentro de las paréntesis a una expresión con exponente usando esta regla, donde el exponente 1, si no ven un 1 es porque hay un 1 invisible. Siempre hay un exponente. 1 dividido por c se convierte en la expresión de exponencial. Y después, ya que ya he convertido esa expresión adentro a una expresión exponencial, uso la regla de exponentes donde tienes un valor, un término con un poder y lo estás tomando a otro poder, los poderes se multiplican. Y convertí b a b sobre 1 porque sabemos que números enteros se pueden escribir como una fracción sobre 1. Cuando se multiplica fracciones, se multiplican los numeradores, 1 por b es b, y se multiplican los denominadores, c por 1 es c. Y se dan cuenta que me dio lo mismo. Por eso, esta expresión es igual a esa expresión, donde el exponente se puede escribir adentro, el exponente del radical, o se puede salir. Es lo mismo. Igual manera aquí tengo una expresión exponente, donde tengo un rational exponent, y lo puedo escribir como una forma radical, donde el numerador es el exponente adentro y el denominador es el index, el número chiquito arriba. Y lo puedo escribir otra manera donde el 2 sale afuera del paréntesis, es lo mismo. También, como se dan cuenta, como es el símbolo de igualdad, yo puedo ir de la izquierda a la derecha, de la derecha a la izquierda. Ahora comenzamos aquí con una expresión radical y queremos expresarla de una forma exponencial. Comenzamos como aquí, comenzamos escribiendo el mismo base y la fracción en el exponente es el exponente dividido por el index, 4 dividido por 3. Aquí es similar aquí, pero el exponente está afuera, pero el exponente sigue siendo el numerador y se divide por el index. Y esa es mi expresión exponencial. Y aquí es similar a la que acaban de ver anteriormente, donde tenemos esta expresión y el exponente se convierte en el numerador y el index es el denominador, pero también se da cuenta que 6 y 3 tienen factor en común, se pueden simplificar y 6 dividido por 3 me da 2, entonces es la misma, son equivalentes. Algo que yo dije cuando lo hice en inglés y quiero explicar aquí, ¿ok? Obviamente, cuando ya no vemos un exponente, el exponente invisible es 1. Y cuando no vemos un index, el número chiquito afuera, es 2, un 2 invisible, siempre. Entonces, para escribir esa expresión como una expresión de exponentes, el mismo base, pero el numerador es el exponente y el denominador es el index. Esta expresión es igual a esa expresión. Y como se dan cuenta, les dije a ustedes, usualmente la van a ver así, sin el 1 invisible, y si no ven un index es porque el index es 2. Si quieren regresar y ver cómo hice los otros problemas en inglés, siempre usando esa misma regla de aquí arriba, y pueden ver o practicar. Gracias.